Okay, so earlier on Piazza, somebody asked the question of how it's possible to visualize the vector space C3. C3. C3 is the set of all column vectors that have complex numbers as their entries and that have three complex numbers, three complex entries. So the question is how you can visualize a space like this. I mean, it's kind of strange because unlike, for example, R3, where the components are real, you can't think of just having three real axes and locating a point depending on its coordinates relative to those axes. Instead, each of the axes in some sense is complex, but since a complex number is composed of two real numbers, it kind of becomes strange to try to draw a picture for how you can visualize a point in this space. But I've thought of an interesting way of doing this because of what someone asked in office hours, and I'd like to share that with you now. So to start with, let's say instead of C3, we try to visualize something a little bit simpler. Let's start with the complex plane itself, C, which you can really think of also just as C1. There's only one complex number that identifies where you are in the complex plane. Now, the complex plane is called that because since every complex number is composed of two real numbers, let's say a plus ib is a complex number, since there are two real numbers that identify that complex number, we could think of each of these real numbers as being one coordinate in a plane. So we can draw a plane here, and we can imagine that the x-axis represents the a coordinate, and the y-axis represents the b coordinate, and if you specify a complex number, you're just specifying a point in this plane. Let's say like that one. So this point here might be something like, let's see, this might be 1 right here, and this here might be negative I, so this complex number would be 1 minus I. So we see that in order to visualize a single complex number, we need an entire plane that has two real coordinates, so to speak. So, for example, to make an analogy, if you're playing the game of Battleship with your friend, which involves you and your friend both having a plane with some axes on it, that you can put a battleship anywhere on this plane. So let's say I put a battleship right here, and my friend also has a copy of the plane. Like so, and he puts his battleship here. In the game of Battleship, the way it works is that you each place your ship somewhere in your plane, and your partner can't see where you've actually placed your ship. So here I am, and here's my partner across the way, and I can't see where he's placed his ship. So what I do is I guess some coordinates for his ship and see if I can hit his ship with a missile. So for example, I could guess the coordinates 1 minus I. So I yell out to him 1 minus I, and he says, well, let's see. Is his ship at 1 minus I? Well, definitely not. You see, it's in this lower quadrant over here, so he's like, nope. And I don't hit his battleship. And then he can guess to see where my battleship is, and it keeps going like that until we guess each other's battleship positions. And the first one to do it wins. So you can imagine that this game of Battleship is like a game of complex Battleship, in the sense that we each have a copy of the complex plane. And in order to guess where the other person's battleship is, we need to guess a single complex number, and that tells us that tells our partner where he should look to see if his battleship is at that point in the complex plane. But now, let's think about what would happen if you were playing a game of C2 Battleship. Namely, instead of having C, each person somehow has a copy of C2, and each partner has to guess where in C2 the other partner's battleship is. Well, that's a little strange because, well, we have two complex numbers that describe a point in C2 now. So how would a game of Battleship in C2 actually look? Well, here's a way of visualizing it. Let me first erase some of this stuff over here. Make room for another Battleship game. Okay, so imagine now that we have people playing a game of C2 Battleship, Well, C2 is specified by, each element in C2 is specified by two complex numbers, the two complex coordinates. So an element of C2 would look something like this, C1, C2, where each of these are complex. And so if we're playing C2 Battleship, each partner should really have two copies of the complex plane. One copy in hand that specifies this first complex coordinate, and the other copy that specifies the second complex coordinate. So you might imagine that instead of having one plane like this, each partner has two, one of which is laid on the bottom of the other one. So for example, here's one complex plane, and now imagine that I put another plane below it, like so. Here's another copy of the complex plane. Here's some axes. And I can imagine now that, you see, this point here that I've specified on the first complex plane, if I think of its projection onto the second complex plane, it'll be at a different location. And similarly, if my friend does this, so let's say he has another copy of the complex plane. I guess I should extend it a little bit more, actually. He has another copy of a complex plane here. He has some axes. And we see if we draw the projection of this point onto his complex plane, his second complex plane, it's somewhere else. So now you see that if you have two copies of the complex plane and you're playing Battleship, then in order for me to guess where my partner's battleship is, I not only need to guess where the point in the first copy of the complex plane is, I also need to guess where the point in the second copy below of the complex plane is. So I need to specify two complex numbers. So now I can't just yell something like 1 minus I and hope to hit the battleship. Now I have to yell two complex numbers. So I would yell something like, okay, I'm going to guess the coordinates 1 plus 2I, and 3 minus I. And then he looks at his planes and, well, I've already missed the first point. It's not 1 plus 2I, but certainly it's not also, the second point is not also at 3 minus I, so he says nope again, and I lose the game. So as you can see, C2 can be visualized by two copies of the complex plane kind of put on top of each other, where one is offset from another, so that the first point represents the first coordinate in C2, and the second point represents the second coordinate in C2. I hope that was helpful for you guys.